Great. Well, I'm going to kick us off. My name is David Witt. I'm CFO at Salinas Technologies, and I'd like to thank everyone for joining us this morning for our inaugural webinar and kickoff for the SonicFinder 1000 in Australia. We're going to keep this pretty quick. We've got 45 minutes. But I'm going to give you a brief outline of who Salinas is and our presenters. And then we're going to have a technical presentation and then a case study followed by any questions that those in the audience may have. If you do have questions, what I'd encourage you to do is to enter them in the question box at the bottom of your screen on the right-hand side, immediately adjacent to the chat box. And if there's any problems accessing that, just jump on the chat and we'll address it as we go along. So without further ado, wanted to give you a sense of who Salinas is. We are a Canadian technology company. All of our staff are specialists in underground infrastructure. We've done everything from capital planning to leak detection to orthotic protection. We have extensive engineering and manufacturing experience, and we build our products, assemble, test, and do QA in Canada. Next slide, please. You may be thinking Canada's a long way from Australia, and we certainly agree with that. And as a result, we're very excited to be partnering with Locating Supplies Australia. And Jeff and Daniel are going to handle our sales, support and service, and our training in Australasia. So speaking today is Mark Bracken, who's our founder and CEO. Mark is a professional engineer, and Brad Horton, who's our VP Sales and co-inventor of the SonicFinder 1000. And with that, I'd like to turn the presentation over to Mark.
Great, thanks, Dave. So as everybody knows, plastic and other non-metallic pipe that's either installed without tracer wire or has damaged tracer wire has been an issue in the locating industry for years. And despite the development of several technologies, particularly on water pipes, the problem has remained pretty intractable. The SonicFinder is really the first technology that is finding widespread acceptance in North America, and now we're moving into Australia. We've grown mainly by word of mouth since we sold our first unit almost exactly a year ago. So we've been in business for more than a year, obviously with the development, but we've only been selling for about a year. I'm not going to spend a lot of time, but the ecosystem of locating plastic pipes is a pretty small one. Two of the technologies, the AML and the Sensit, were actually discontinued in the last couple of years. So the main technology that people use and the most common is probably GPR. And we consider the SonicFinder to be a companion technology to GPR, especially where soils are impractical or geometry of the area is impractical for GPR. So the SonicFinder consists of two components: the handheld actuator that you can see on the left and the sensor unit that you can see on the right. The sensor unit in this case is located on a gas valve. The actuator imparts a vibration to the ground, which is then picked up inside the pipe, in the pipe wall, and the fluid inside the pipe travels through the pipe to that sensor. And very simply, the concept of the technology is incredibly simple, and that you move across the pipe in a perpendicular direction, and when you're directly over it, you get a maximum, which is then seen by the operator on the left. There's a screen on the unit that you'll see very shortly. So the device is very, very simple to use. Under the hood, though, there's a lot of technology that we've had to do to make this thing work properly. So to summarize the steps, first, the unit is the sensor unit is placed on either a gas valve, fire hydrant, water valve, anywhere you can access the pipe. Second, we move along the buried asset in a perpendicular direction on a series of scans, much as you would with an electromagnetic actuator, and you locate and you mark where the pipe is, where you get a maximum in the level. So this shows a typical field setup where locators are shown scanning across two pipelines. Typically, we'd start at a location close to the sensor and move progressively further. Here we've shown sensors mounted on a gas meter and fire hydrant, but as I said, this could be a water valve, service valve, or even a sewer washout has been done. The unit, the radio senses the signal, sends it back to the actuator, and you read a real-time vibration level that we're imparting to the pipe, and where you're right over the pipe, you get a maximum. So how does this work? And why is it accurate? I think many here will be familiar with plastic pipe locators for water pipes, for example, the RD510, that work by placing a noise source or thumper on the fire hydrant and then following the sound with a ground microphone. What we've done is essentially turn this upside down, where we are imparting a vibration signal to the ground, and it's reaching the pipe and then traveling through the pipe to a sensor. The advantage of this essentially is that we can impart much more energy to the pipe than you can through a thumper in the fire hydrant. So the distances we can go are very far, and we don't need a fire hydrant. We don't need to be connected to water, so it works on gas pipe, sewer pipe, and all the others. So the wave that goes down from our system is called, to seismic engineers, they know it as a P wave, a compression wave. And because soil does not transmit shear very well, this remains as a pretty tight signal. In other words, it doesn't spread in a cone shape. It goes directly down to the pipe, which means it's quite accurate. So we don't have a very, like a 2 meter wide cone of vibration that goes down. It's very, very narrow. So we've had, depending on the pipe and the soil, we've had accuracy with this piece of equipment down to almost centimeters with small diameter pipe. It's really quite remarkable. You won't always get that, but we've had that level of success with this. I'm now going to pass this over to Brad Horton, our VP of Sales, who's going to take over the presentation from here. Brad?
Thank you, Mark. Good morning, everybody. The SonicFinder 1000, dirt is the key. It works far better in dense, compact soil, which GPR carts are notorious about not liking as well. Water tables, that sort of thing, don't affect this signal like they do a GPR. So when Mark said that they're a complementary technology, they really are just that. The GPR does great in sand, more loamy type soils. We pick up where it starts to trade off. Is it just in dense, moist clay that would stymie a GPR? This unit just works incredibly, incredibly well. Distance wise, for water pipes in dense, compact soil, we've had up to 300 meters, 200 to 300 meters. That same pipe in a loose soil, you're going to be half that, or maybe even a little less than half. Additionally, water versus gas. Water carries the sound much more efficiently, and we'll talk a little bit about that later, than gas does. So you'll get a lot more distance on water than you will gas. But it does work on all pipe types, water, gas, sewer, as well as pipe material types. You can use it on C900, asbestos concrete, and so forth and so on. You can use it on metallic pipes as well, but if you've got an EM locator, you'd be far better off using that. Mark? So the screen of the SonicFinder, there's some icons across the top. Starting at the left, you've got a time. Then you go to G, which stands for GPS. This is not survey grade GPS. This is merely I'm in a couple of meters of this location. The next icon over is your radio hookup, your link between your sensor and your actuator. And that's displayed with a black R or a white R in a black box with some bars next to it. When you go out of radio range, you'll see those bars start to dump off. Then the last two icons are battery icons. One is for the sensor, which is S, and then D is device, which is the handheld device you have in your hand. Going through the rest of the buttons just really quickly, right below the screen, there are 11 LEDs that go across that sort of mimic what you're going to see on the screen. As you're looking at the screen, you've got the large numbers, the large 0.0. That is going to be the same as your signal strength on EM. That will give you your active locate. There are 3 numbers underneath that are your histogram. That will show you your last 3 locations so that you can kind of keep track of where your elevated number, your highest amplitude is. And then just to the right of the 2 large numbers, the 2 large zeros, there is a real-time audio number that is displayed. And this lets you know if your background noise is high or if there's something happening out there, maybe that you can't hear, but the sensor's picking up. It will show you that there's an elevated noise level. Also, when you actuate this, when you trigger it, if you look at that number, it kind of gives you a preview of what your final signal strength number, the double zeros, are going to be, your amplitude. So that is about it. You've got on the left-hand side of the screen, you have the arrows that control your gain. The gain goes from 1 to 7, 1 being the less gain. That's where you always want to start out with, the lowest gain, and then go up as you need to. The up and down arrows on the right are for your frequency, and you simply press those, scroll through them. This operates between 50 hertz and 200 hertz. So you just run a frequency scan, figure out what the best frequencies are. We'll go through that in a minute, and that will give you that. Next one, Mark. Okay, in the menu, when you go down at the bottom, one of the bottom buttons down there says menu. You press it once, and it is menu 1 of 2. You press it again, it becomes the second page of the menu. Use the up and down arrows to move to whatever function you would like to access, and simply hit enter, and that'll bring it up. The top one is frequency scan. That is the one you will use the most often. Pair devices, they're already paired coming from the factory. You should probably never, ever use that button, or probably will never have to. Output level determines how much output the actuator is putting out. The only time you're going to use that is if you're really close in to like a gas meter, gas riser. Sometimes you'll get soil-borne vibration, which go across the top of the soil to the sensor, and we want to avoid that because we want to locate the pipe and off the top of the soil. So you may want to turn it down. And then the rest of them are pretty self-explanatory. There's a IR threshold for the infrared sensor that you use to actuate the unit. GPS info is just going to tell you where you're standing, time zone, et cetera, et cetera, et cetera. So that's it. Go to the next one, Mark. All right. The frequency scan. Whenever you go to a site, the first thing you're going to want to do is set the sensor up, move out about 3, 4, 5 meters, and run a frequency scan. This takes about 3.5 minutes. And you see the bottom right picture of the screen there. This is what it's going to give you as a display after you run the frequency scan. It's going to give you a graph, which will show you what level the different frequencies have come in as far as being received by the sensor. And then down at the bottom, you'll see it says 3 peak. And in this case was 75, 90, and 100. This does not mean it will only work at those frequencies. It will obviously work at others, but these are just the best. This is what the sensor got the highest readings on. It's a starting point. As you move out from the sensor and go down the pipe, you may get out, 30, 50 meters or so, and signals start to drop off. You can run another frequency scan, and see. And normally what will happen in that case is you'll see the best frequencies have dropped. So that 75 is our lowest. That may now be down to 65. So once you learn your area, if you're on Main Street and it says 75, 90, and 100, the next time you go to Main Street, you can just set it at 75 and start there. You will see differences, though, if you're at the bottom of the hill versus the top of the hill, because the soil changes. If it's rained versus the last time I was out here, it was really dry. The rain, the soil being saturated by water, that may affect the best frequencies. So again, the range is 50 to 200. I can honestly say I don't think I've ever had anything go above 150. That's not to say it won't happen someday, or it may be beneficial to go up that high to avoid some other issues. With frequency, lower the frequency, the broader the wavelength, the more vibration that you have. The higher frequencies, you kind of do away with a lot of that vibration. So if you're around empty structure like catch basins, or if you have a sewer lateral running underneath the line you're attempting to locate, right in that area, a higher frequency is going to have less interference, less error than a low frequency. But it becomes really intuitive when you're out using it. Next, Mark. All right, we have 3 different spike sets that we use with this, little short ones. And honestly, I put the short ones on my unit, tighten it down, and I leave them on all the time. They don't negatively impact if I'm using the longer spikes. And there is not a single situation where you will not use the spikes. The short spikes, asphalt, concrete, hard pack. The medium spike is for clay, compact soils, that sort of thing. The large spike for sand, what we call gumbo, which is just basically swamp. That's when you'd use the larger spike. So spike selection, pretty critical. If you put the big spike on, a lot of people are like, oh, I just want to use the big one because that's probably the best. And then you only get a few centimeters of it in the ground, and you're really you're not benefiting yourself. Use the shorter spike. When you're using this, consistency is the key. If you're sticking it in the ground repeatedly and all of a sudden you hit a gopher hole or mole hole, don't take a reading there. Move it 2 or 3 inches out of that till you get back into consistent soil types. When you're using the 3 spikes on asphalt or concrete, it's fine to rest your foot or toe or hand on the unit to keep it from walking as it vibrates. When you're out in the field, if you're in the grass, if you put your foot on it for 1 reading, put your foot on it for all the readings. Consistency is the key. So next, Mark. We have a number of utility companies and contract locators that have used our equipment. Several of them have been asked to use our equipment by their bosses and by the people that they contract for. Probably at this stage, about 80% of the units out in the wilds are with water customers, city of, town of, village of. It's been embraced by these water guys that haven't been able to find some of their pipes for years because they're plastic and were installed with no tracer and they don't have great maps. So they found it extremely helpful. Probably 15%, maybe 12% are gas companies like PG&E in the States and several others, Wisconsin Gas, Midwest Gas, Virginia Natural Gas, and so forth and so on. And then the last percentage is contractors, people that are actually doing like turn back work for gas companies or have to do a lot of plastic service line locates for gas companies. And then we've got a few SUE companies like T. Baker Smith that are using it on projects for their pre-digs. When they go out to locate a project, they carry this unit with them in case there's any lines that they can't find any other way if GPR doesn't work or EM doesn't work. So we're starting to see more and more. And the nice thing is we're starting to see repeat business where they originally bought one and they come back and they're like, oh yeah, we need another one of those. So that's a really good thing as well. Mark. So this case study, I was in Northern Ohio here in the States, and I was with a contract locator, and he got a phone call while we were together, and it was the local gas company. Said they had a long side service that they were, you can see there in the picture, digging a hole and couldn't find. They had a hole about 1.5 meters wide, 1.5 meters deep, and about 3.5 meters long, and they were digging to the east. I went out and hooked onto the long side service they were trying to find. Basically, what they were doing right there is chasing main. They dug down, found the main, because it had a wire on it, they could locate it. And then they were just using the backhoe to chase the main to try and find this service tap. So we hooked onto the meter riser at the house, came across, and it was literally about 1/3 of a meter outside of the hole they had dug in the opposite direction they were digging. So it was just to the west of where they'd already excavated. Repositioned the backhoe, took about 3 scoops, and found the broken tracer wire. So they had traffic control out there, 4 guys from the gas company, 2.5-ton dump truck, backhoe, low boy, the whole 9 yards. So that's probably about a $25,000 hole they're standing next to, that it could have been done with 2 guys with shovels if they had known where the service was. So, next. Down in Australia, Pulse Locating contacted us right when we first came out of the gate. And the gentleman that called me, Chris, was, hey, if this thing works, man, it'll save me a ton of time, because what he was doing was basically hydro excavating in the front yards. There's a bore crew coming through installing fiber, and he had to locate all of the services from property line to the house and excavate them, drop a marker ball on them, note it, measure how deep they were, and all that for previous. And what he was doing before he got our unit was literally just taking his hydro excavator, going out there and go for hole. And, sometimes he'd hit it on the first hit. Sometimes it'd take 2 or 3. Got our unit and said, man, this is great. I locate it. I get my hydro excavator out there. We dig down, spot the crown of the pipe, drop a marker ball in, measure it, document it, and then take a shot on it with our GPS, and away we go. So a huge time saver for him. At the time he was like, yeah, this is probably cutting my time down 30%. So definitely easy to calculate ROI on that. Next, Mark. So we've had a bunch of other success stories, again, across the U.S. I know the guys in Australia that have been testing the unit for the last few months have also had success stories they can share with you. But these are just a few of the posts that we've seen on LinkedIn from folks that are out, using the unit, seeing the unit, and having success with it. Next, Mark. We will now open this up to any questions that anyone in the audience may have. Feel free to sing out. Remember, there are no dumb questions, only dumb answers, and those are me.
We do have one question in already from Simon Newrick, and he asks, in Perth, we have a lot of polygas services fed through old cast iron and galvanized steel pipes. Do you think this device would still be able to detect these within the old services accurately?
Yep, I got you, David. Inserts are a coin toss. If the pipe inserted into the old steel is touching the old steel enough for the energy to transfer, then you can locate it. I would say I'm about 60% on insert pipes. 60% that I can find, and the other 40%, there's just not enough connectivity between the inserted pipe and the pipe it's inserted in. If there's good contact, it works. If there's not, and it's one of those things where you can get it at this point, but down here, maybe it's not touching as much or not touching at all, and you don't get it. So it's very much a crapshoot on inserts, but it will work.
Great. Thank you, Brad. And we have another question from Chris Werner. How does it go where a service tees, example on a water main?
Yeah. So I don't know if you're asking about a tee or the saddle, but I love hooking up at water meters. It seems like we get really, really great response going from water meter to main and then down the main. So it does translate through 90s. Now, you do lose energy anytime you go through a 90, right? You've got, just like with EM, and you're trying to locate where the 90 is, and it's very confused because of your antenna orientation and the electromagnetic field orientation. With this, that 90 is going to rob a little bit of the energy going down the pipe. Again, so straight shot, you can get, let's say if you get 200 meters on this at a straight shot, if you throw a 90 in there, maybe that's back down to 180, 170 meters. So it does affect it. And when you come to a T, which I think maybe what you're asking, the energy goes both ways, comes in and goes both ways down the T, you are, losing an amount of energy off that singularity. But still, I've done meter domains on gas and water, and still getting, a couple hundred feet in both directions from where the saddle is, where it's tapped in.
And Brad, I have a practical example that I did in a lumber yard where they were trying to locate a 6-inch PVC main that was going into the lumberyard building. And we had access on a fire hydrant that was teed off the main by about 20 meters. So what we were able to do is we were able to locate that tee. So we put the sensor on the fire hydrant, moved down the main, and was able to locate it pretty accurately. And as soon as we were beyond the tee, the signal just died. Like, we went from very good signal to zero, literally within sort of, 300 millimeters, 30 centimeters of the main. Like, it dropped off immediately. So we knew pretty much precisely where that main was. So we were able to locate the T, and then we were able to go both directions on the main, down another probably almost 80 meters. And this was under asphalt, by the way. This was not under soil, and keep locating that main. It was a pretty interesting little project that we did there.
Mark and I are highly competitive, and we find all these different things that I did this. Well, I did this. So we've been surprised, happily surprised several times at some of the things that it does do really, really well.
And surprised at some of the stuff that Jeff has done in Australia when he put the sensor on a manhole cover and was able to locate the sewer. Maybe we'll get.
I ran out and tried it after he showed that, and it worked. So actually, that's how I locate my septic line in my backyard. Is I just put the sensor on top of the lid, and away I go. I see we have a question from Robert asking how well it will work in a high traffic area where there's a lot of vibration and noise. Robert, the answer is it depends on the amplitude of the noise hitting the sensor. Again, back to the screen in that upper, the right-hand corner, there is a real-time noise level that it's showing you all the time. And even when you actuate it, that gets factored into that, and you'll see that number go up, showing that it's receiving the actuation that you just did. As long as your amplitude from the actuator is 6 dB or more above that noise floor. So if that noise floor is 26 and you're getting, say, 44s for your number over your target, you're fine. When you get into areas where that noise level, Mark and I were at one in London, Ontario, where we were in an industrial park and they're running grinders and CNC machines and all kinds of heavy equipment. It didn't work. I mean, there's just sometimes that threshold is too high. But for traffic, Glennis, you asked about high traffic areas. Traffic is not a constant, right? An idling backhoe next to your sensor is going to kill you every time. But traffic with that ebb and flow, if you can kind of get in those quiet spots in between, when lights turn red or whatever, then you've got a really good chance of it working and working well enough for you to be able to do your locate. It's a lot like leak detection in that, where I just did one in Montrose, Colorado, and we had to go out at 8 o'clock at night to do it because during the day the traffic was just a high traffic area, and saying we were right next to a light. So even when the traffic wasn't moving, it was still a truck idling right next to where my sensor was going to be. So I just went out and did it at night.
And I just to add to what Brad said, is what I've found in heavy traffic is you'll be able to locate, but it'll limit the distance that you can go as the signal gets lower. Generally, and I don't want to start giving a number of meters because it depends on the soil and all that, but you can locate, and then you just can't go as far as you could in a quiet area.
Great. Thanks, gentlemen. We've got a couple more questions and only about 12 minutes left. Simon Nerwick has asked, does the vibration bleed off to nearby services?
Excellent question. The only time that I've ever experienced what I would call true bleed over or bleed off, it was a water service, and when they had installed the French drains from the downspouts, they had literally laid the French drain on top of the water service. And you're going up through there, and I start veering off this way. Well, I went to a downspout here, and this went to the middle of the house where water services go. So just a little bit of situational awareness there, and I could discard that other signal. One thing that will happen if you're doing, say, a water service at a house, you may pick up that gas service because the gas meter is bolted to the side of that house. So there's a great dense house foundation wall with the gas meter mounted to it. And you're over here exciting the water, and it's exciting that wall when you're closer to it. It may light up that gas service a little bit as well. But again, we're locators, right? Locate it out, make it make sense. If you're locating the line, you come to a valve that says gas on it, you're probably on the gas line. And same way with houses. I mean, I'm not sure how they do them there, but here the water service usually goes in somewhere in the middle of the foundation, and your gas service is off to the side. So it's pretty easy to tell which one's which.
And again, just to add to that, I was in California locating an asbestos cement main, and we got a max over where they pretty much knew the AC pipe was. And then I got another one as I moved out because they weren't telling me where the pipe was. And it turns out I was locating the sewer as well. So the same as you have with electromagnetic locating, that sewer pipe was actually carrying the signal back down, and there must have been a lateral that was close to the fire hydrant. So it wasn't as high as the main itself, but I got a phantom reading off the sewer main as well. So you have
part of the reason
it's locating, and you get to understand.
Part of the reason it will light up sewer, especially at lower frequencies. And if I remember right, Mark, you were at a pretty low frequency there.
Yeah.
That broader wavelength at the lower frequencies, an empty sewer pipe turns into a big echo chamber, right? So you can, where those laterals go across, to Mark's point, you can excite those as well. But again, it's pretty easy to differentiate between the two. I haven't had any yet that I was had bleed over and didn't know that I wasn't on what I wanted to be on.
And because we've had a few questions on this, the other thing that I know both Brad and I have done is if you've got your sensor, let's say on a water valve, and you're locating the main, you can also use that same sensor location to locate the water service. If you'd want to go down the water service, this vibration will transmit up the service into the main and down to your sensor as well. And I know, Brad, you and I have both done that.
Yep. Yep.
Great. Great. Next question from John Cording. What size pipes can this detect? For example, could it be used on mains, 100 millimeter and above, water from setting up on an inline valve or hydrant?
Well, I have done everything from 1/2 inch or 20 millimeter services all the way up to, and Mark, you'll have to help me with the translation, 36 inch. I don't know how many.
1 meter.
That,
Yeah. Roughly a meter.
yeah. So 1 meter pipe down to 20 millimeter pipe. And the 1 meter pipe is actually a concrete pipe. Now, the larger diameters will shorten distance because the energy, burns off more in that big pipe than it does a small pipe, but you're still going to be able to locate.
And the largest PVC pipe or plastic pipe that I've done would have been a 12 inch or a 300 millimeter. And it worked great on those. It's worked. Yeah. We've done lots of 150s, lots of 100s. Yeah, that's pretty common.
Great. Next question from Chris Warner. What kind of depth does it work to? Does it depend on soil type?
Yes, it does depend on soil type greatly. We've done a bunch of pipes under 3 meters deep. They're over 3 meters deep. Salmon Arm, British Columbia, a lot of the stuff Mark's done up around London, up in Saskatchewan, I think that was 3 meters. I mean, basically everything in Canada is 3 meters deep or deeper because of freeze lines. So we don't know how deep it will go. There's a case study that just got published in OpFlow magazine, which is the American Waterworks Association publication. And the kid that case study is based on, he found a service board under a creek, like, I don't know, almost 4 meters deep, 3.5 meters deep. So, but he's in dense, compact, moist clay. So he's in surgical conditions for using this. But the truth is, we don't know how deep it'll go. We just don't know yet.
The deepest I've done, again, was probably that 12-inch plastic main in Calgary that was about 3 meters deep. And it was no problem. I think obviously the closer to the surface you are, the higher the vibration level that the pipe gets will be received. But all the testing has been done. All our development was done in Canada, where, as has been noted, the pipes are very deep. So, and it works like a charm in most of our soils here.
And Mark, can you explain why the device works more efficiently on water than gas?
Yeah, so when the wave goes down and hits the pipe, it travels in 2 different ways. It travels through the pipe wall as well as whatever fluid is inside that, fluid or gas. In the case of a water pipe, it actually then goes into the water and travels primarily through the water. When it goes through a gas, that also happens. It travels through the gas. And very simply, the water is a more efficient conductor of the vibration than gas is. Therefore, it works on gas, but typically we use it on gas services that are shorter than gas. Although we have used it on gas mains, it won't go as far in gas pipes as it will on water pipes.
Great. And it is worth noting that Pacific Gas and Electric in the United States, which supplies all of the gas in California, have done extensive testing with the unit and have rolled out a unit to each of their regions for further testing. Great. Jeff
Tree
Moore.
roots. Yeah, maybe Brad just comment on tree roots, the comment from Jeff.
Yeah. So tree roots are obviously more dense than soil and will carry the sound better, the vibration better. So if you're located, we've got a YouTube channel, and I go through this on it as well. If you want to check that out, if you are off to the side of your path, your pipe path is right here, and you're off to the side of it, and you get this crazy erroneous high reading, it may be because the tree root comes out and goes down right by your pipe, and you're over there, you've excited this tree root, and it has carried more energy, more vibration down to the pipe, and has given you this really high reading when you're obviously outside of the line of line of flags that you've done. I did a lot of work in West Virginia with this early on as well. They've got a lot of sandstone, so big slabs of sandstone rock. Same thing. You could go 3, 4, 5 feet off the side. If you were just exactly the right spot and actuated, you got this crazy high anomalous reading. But if you move 2 feet in any direction, it goes away. It's not repeatable. It's there is no locate there where you're like, okay, I got a hot, crazy high reading here, here, here. That doesn't happen. But they can give you single anomalous readings as you're going down the pipe. So if you're around trees or in really rocky soil, it's just something to kind of keep an eye on. Drop your flags, get to the end, turn around and look. And if one of them's a flyer out to the side, that's just, you've been on a tree root or a rock. So you can pull that one and go on.
Great. And we've got a couple of questions from Jason Chang. Brad, can you see those?
I cannot. They're not up on chat.
First question is compared with a leak noise correlator, how does your equipment perform in terms of leak pinpointing, efficiency, and accuracy?
Yeah, we don't do leaks. We're not a leak detector. It's the sensors have some similarity to the sensors that you would use on a correlator. But we're not looking for anything in that range of frequencies. We're not looking for anything there. So
But maybe, Brad, maybe it's a good opportunity. What kind of accuracy have we seen with our unit in terms of how accurately do we locate the pipe?
Well, in soil, I think we're within, and I'm going to use inches, we're within 6, 8 inches of center on soil for pipes, 3 feet and greater deep. Shallower than that, it's a lot tighter. When you move to asphalt or concrete, because you're vibrating that bigger pad, you're going to be maybe, call it 10, 12 inches, variance. But again, it's pretty darned accurate. I mean, it's if you're digging with a backhoe, you're going to find it where you marked it.
Great. And does the device have pipeline surveying capabilities?
Pipeline surveying capabilities.
And also, if so, does it differentiate between plastic and metallic, Brad?
No, it does not differentiate between materials. And no, it really wouldn't do any of your pipeline confirmation as far as, I don't know if he's talking about CP or, I'm not really sure. If you could maybe give me a little more information on what kind of documentation he's looking to be able to provide. But all this does, look, we tell everybody, EM first, that's your first tool in the toolbox. You've got milliamperage, you've got depth, you've got signal strength, you've got all these great data points that come from having an EM locator. With GPR, you've got depth, you've got hyperbola shape, you've got whether it's double hyperbola or not, so you can tell whether it's plastic or metal. But so you got all these great data points. All we're doing is telling you the highest number is here. There is no depth. There is no other data point. It's simply this is where the number is the highest, is right here. So if you can use an EM locator, use an EM locator. If you can use GPR, use GPR. Your data is going to be much more rich. We're just going to tell you, hey, you go across the yard and the numbers go up right here.
Great. Thanks, Brad. Now, we may get cut off by our platform. We can continue answer questions, but in the event that we do get cut off, I'd just like to thank again.
Go to the next slide, Mark, if you don't mind.
I'd like to thank again Locating Supplies, Jeff and Daniel for hosting us and being our partners in Australia. They're trained, they're fully competent in the use of the device, and we're looking forward to much success with them.
Thank you.
And there's all their contact information up there. You can email them. You can email us. We're info@Salinas, and I'd be happy to answer any questions that you have or expound on anything that you'd like for me to.
Great. Great, thank you. Now, if there's any other questions, we can keep going.
We have one more, Dave.
Oh, on the chat, excellent. No, I think that's
Does the device estimate depth at all? Do you want to take that, Brad, or shall I?
Well, the answer is no.
The answer is no. We are looking at a future feature to do depth, but as Brad said, right now the answer is no. It does not estimate depth, but we're experimenting with various algorithms that we might be able to do it with firmware upgrades in the future.
great.
That's it, Dave.
If there's thank you, everyone. If there's no further questions, we'll let everybody get back to work. Have a productive day. And again, if there's any questions, please feel free to follow up, I would say initially with Jeff and Daniel. And if they don't have the answers, they'll be certainly in touch with us immediately. Great.
Thank you, everybody.
Thanks, everyone.
Thanks, everybody. Thank you for your time.
Thanks, guys. Thank you.
Yeah, hang on a sec, Jeff.
Mhm.